So here we go. This is on using proportional relationships, and it goes with your textbook lesson 12.3. Your essential question, how can you use similar triangles to solve problems? And your learning goals are just this one. I can apply similarity proportions to solve real world problems. There's a little bit of review. This is something we've already learned back before we went on break. Okay, we learned about angle, or AA, the triangle similarity theorem, which says if two angles of one triangle are congruent to two angles of another triangle, then we can say the two triangles are similar. Remember, similar means the same shape, but not necessarily the same size. Okay, we have congruence theorems and we have similarity theorems. And this is the same theorem again, just written a little bit differently. Instead of calling it a theorem, they're calling it a postulate, which is fine. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So those is exactly the same words, but here you have a picture to go with it. So you have triangle ABC, triangle DEF, and you can see that A and D have the same measure. B and E have the same measure, so you have two congruent angles, and that's enough information to conclude that triangle ABC is similar to triangle DEF. And this little wavy symbol here, that's the similar symbol. It's like the congruent symbol is different. Okay, so you have like the wavy, and then you have the equal sign for congruence, but when it's similar, it's just the wavy part. Look at that, we're already halfway through. Vocabulary. So only one new term here. If I talk about indirect measurement, what that means is that it involves using the properties of similar triangles to measure heights or distances that are too great to be measured directly. All right, so these are the types of real life situations that similar triangles can help us figure out measurements when they're too large to just like get a tape measure and measure it, or a ruler and measure it. So this is the first example here. I'm going to go ahead. Why is that like that? Am I on student pace? No. Oh, okay, there it is. That work? I was wondering what it was doing. Okay, so anyhow, this is the first one I'm going to explain to you guys, and so you can draw on this slide too if you want to. You don't have to, but this is finding an unknown height. Okay, and so we are going to find the indicated dimension using the measurements shown in the figure and the properties of similar triangles. So for this first one, it says in order to find the height of a palm tree, which would be difficult, you know, you measure the tree's shadow, which is something you can do because that's along the ground. And at the same time of day, you measure the shadow cast by a meter stick or some other thing, and you hold it at a right angle to the ground. So it doesn't have to be a meter stick, but in this case, we're using a meter stick. So we have 1 meter here, and then we have this palm tree here, but because it's the sun's rays are parallel, they're coming down like this, it creates this right angle here, and this right angle here, and then we also have a common angle here and here because of the way the sun's rays shine. So you get a proportion between the two shadows that are cast, okay? Because ZX is parallel to CA. So this line right here and this line right here, these are parallel because these are the sun's rays. I haven't drew a sun like this in a long time. I have no reason to ever draw a sun like this except for right now. I haven't drew one like that since I was a little kid. Okay. Sorry. So yeah, that's where this comes from. Those are parallel. And because they're parallel, that creates the fact that these angles here are congruent, Z and C. Okay, so that's this angle and this angle. And all right angles are congruent. So the right angles are congruent, which is this one and this one. So we can even say then that these other two angles are congruent, y and b. Oh, no, wait. So sorry, y and b are the right angles. So XYZ is congruent to, no, it shouldn't be congruent. It should be similar. They're similar. The triangles are not congruent. That's a typo. So we're going to fix that. That's interesting that they have a typo in the math book. Okay, that's fine. What's the code? Right here, I'll put it in the chat for you, Marco. And I'm going to get the pencil tool and resize it. So, you know, we've actually just shown that these are similar. These two triangles are similar. They are not congruent. So you need to change that. I don't know, there's just a typo in the book. Sometimes that happens in math books. Set up a proportion. AB to XY is equal to BC to YZ, right? So we're plugging in the values we have. This unknown height of the palm tree right here is what we don't know. But if I compare that side to this side, and then I said equal as this side to this side, that's one way to set up a proportion. And I can solve for h by multiplying both sides by 7.2. And then we get the answer of the height is 4.5 meters high. All right. So similar triangles are useful if there is something that you can't quite measure, so you can indirectly measure it. Right here, that's the vocab term, indirect measurement. That's what this is. Okay, so you can indirectly measure that. The only thing you really need to do to this slide, I think, is change that congruent symbol to a similar symbol. Okay, these two triangles are not congruent. They're similar. They are not the same size. They are the same shape, so that needs to be changed. All right, next slide here. We're going to do this one together. Sid is 72 inches tall. To measure a flagpole, Sid stands near the flag. Sid's friend, Miranda, measures the length of Sid's shadow and the flagpole shadow. And we're going to find the height, h, of the flagpole. All right, so, you know, we have this like real life situation, but we just have these two little pictures here. You could kind of see the flag is here. So if you want to draw in Sid as a little person, you can do that, right? Sid is right here. He's standing here. He's 72 inches tall. Sid is 72 inches tall. So here is Sid. Sid is 72 inches tall. So Sid is standing right here. That's my wonderful Sid picture. And then we don't know the height of the flagpole, right? But here's our flag. And that one is already drawn in for you. So we want to measure that. It's going to be h. So we're going to use h as the height of the flagpole. That's what this is, h. And we can just create a proportion. And we can figure out how high the flagpole is by measuring the shadows on the ground. Okay, so we're going to set up a proportion here. What number will go here? Let's see. Oh, actually, these are words right here. So something height over person's height is equal to something shadow over person's shadow. So we're comparing the person's height and the person's shadow in the denominator. So up above, we're going to put the flagpole's height. Flagpole's height. And again, flagpole's shadow. Okay. And so you guys should be kind of following along with this. Okay, see where you're at. I'll show some responses. Okay, so there's mine. There's this person. So you should be writing on your Pear Deck slide right now. I have 9 of you doing that so far. Okay. And now we're going to substitute next. So the first step here, step 1, was to set up a proportion. Okay. Now we're going to move on to step 2. Step 2 is to substitute. We're going to substitute in something here. So step 2, we're going to replace these things with what they're equal to. The flagpole's height is h. That's why there's h here. The person's height is 72. That goes here. The flagpole's shadow is 128. That goes in this box. And then the person's shadow is 48, which goes down here. Now, I don't know why they... oh, no, they did. Never mind. Never mind. They didn't do anything. So I'm going to type in 128 in this box. Okay, so we're going to type 128 in that box. You can always resize your pencil over here, the sizer, okay, because it will be like this giant thing that you're writing with. It's kind of hard to see that a lot of times. All right, now we're on to step 3. Step 3 says to multiply each side by 72. Okay, so we're basically solving the equation in the third step. Since h is being divided by 72, we multiply both sides by 72. And so we still have in this little box here, 128. Okay. And then we're going to simplify. So 72 times 128 divided by 48. You can use a calculator. Let's see if anybody's figured out the answer yet. What are we going to get when we simplify? Here we go. This person figured it out. 192. And then they put in the correct units right here, which is really nice. So good job on that. X. See, what is happening with this lesson? Look at that. They went from H and then they switched it to X. Oh, I'm disappointed in the book today. So you got to change that. It's not X. There's no X. It's H. What is happening? They had the wrong symbol. They had the wrong variable. This is crazy. I'm very concerned about who wrote this chapter. Oh, okay. All right, so anyhow, our value, we're going to go ahead and put that in here, 192. And over here, 192. And now you want to include your units. It's 192 inches. All right. Okay. Do any of us have any questions about this slide before we go to the last slide? You can come off your mic and ask, or you can put it in the chat. All right, so That's not it. Oh, right here. So I'm going to put you on student pace. Okay. And then we're going to go to the last slide, which is slide 6. Okay. I'll leave this here for a little bit longer, but I go to slide 6. Says a man 6 feet tall cast a shadow. And here we have an actual person of a picture of a man, much better than my stick figure. Shadow 4 feet long. At the same time, the flagpole casts a shadow 20 feet long. All right, so this is a very similar problem to what we just had. And you're going to find the height of the flagpole. So you're going to use the last slide, all right, as an example. And you would just go through these steps. So you're going to first set up a proportion. Then you're going to substitute in the values that you need. Multiply each side, not by 72, but by whatever you need to multiply by. And then the last step is to simplify to the answer. Okay, and you want to write your correct answer using the correct units. So we're not in inches anymore now, we're talking about feet, which, you know, I think is really makes a little more sense. I don't know. You know, if you say something is 192 inches, I don't really have a very good mental image of what that even means. But if I convert that to feet, I feel like that I can visualize better. But whatever, it's just a math problem that they made mistakes on and used an X instead of H, and they used a congruent symbol instead of similar. All right, so you guys are going to try this last slide. I have 3 of you that have already started, so we'll do like a little timer. This is it for today, so I'll give you like 5 minutes. Do the last slide. I have 4 of you working on this so far. Where are the rest of you guys? You should be working in your Pear Deck. Doing slide 6. Six of you are now working on this. 7 of you. 9 of you working on this out of 26 of you. Where are you guys? I'll be on slide 6. Now, a couple of you are still on the previous slide. Some of you are just sitting in the meat. You're not on your period. Aiden, Alyssa, Anthony Cruz, Blake, Braden, go to your Pear Deck tab. Elijah, go to your Pear Deck tab. Aiden, your Pear Deck tab. You can open it for you guys, Elijah and Jaden. Mia, go to your Pear Deck tab. All of you. Okay. Just to clarify, when you are setting up a proportion, there's not only one correct way to set up a proportion. There are like a few different ways that you can do that. Okay. So let's see what we came up with. This person has 20 over 4 and h over, I think that's a 6, which would work, but you want an equal sign there. This person has h over 6 and 20 over 4. That works. This is a way that you can set that up. Here we have h over 6, 20 over 4. Okay, yeah, the height of flagpole is 30 feet. This works. 30 feet exactly. H over 6, 20 over 4. That works. H over 20 and 6 over 4. This also works. They have the correct answer. I don't know how they got it. Okay. H over 6, 20 over 4. Yeah, so there's a couple different ways. So like this person did h over 20 and 6 over 4. That's okay. Because if you solve this one, you're still going to get 30. So like right here, if I pull over a calculator, they're at 6 divided by 4. It's 1.5 times 20. You still get 30. Okay, so there's not just one way to set up a proportion. Yeah, so that's the correct answer. I like how this person used all the color coding. It's nice. I'll leave it right here. So I'll leave this as our solution. Okay. Do you have questions on any of what we learned about today?